Hello and welcome to today's web seminar, 3 Keys to Performance Testing at the Speed of Agile, sponsored by Neotis and featuring Paul Bruce, Senior Performance Engineer at Neotis. I'm your host and moderator, Josiah Renaudin. Thank you for joining us today. Before I hand it off to the speaker, let me explain the controls on this console. If you experience any technical issues, please send a note through the question field located beneath the panels, and we'll be on hand to help as quickly as possible. Our responses can be read in the Q&A panel to the left of the slides. This is also the same way to submit questions. We welcome all comments and inquiries during today's event, so feel free to ask as many as you'd like, and we'll answer as many as possible during the Q&A session at the end of the presentation. This event contains polling questions, which can be answered within the slide view, as well as a live demo. To optimize your bandwidth for the best viewing experience possible, please be sure to close out any unnecessary applications that may be running in the background. At the bottom of your console is a widget toolbar. These widgets open panels. The console opens with 3 on your screen: the speaker, Q&A, and the slide panels. All of these panels can be moved around and resized to your liking. If you accidentally close one, click the respective widget to reopen the panel in its original place. Hover your cursor over these icons to reveal labels identifying each widget. Through these icons, you can download the speaker slides and white papers, as well as share this event with friends and colleagues. This event is being recorded and made available for on-demand viewing. Once the recording is ready, you'll receive an email with instructions how to access the presentation and slides on demand. With that said, I'd like to introduce and pass the controls to our speaker, Paul.
Thank you, Josiah. I also want to thank Neotis, and I want to thank TechWell for sponsoring this, and particularly for hosting this. It's a really great opportunity for us to share ideas and then also be able to sort of collaborate afterwards about some things that maybe come up and that people are interested in. So what I'd like to do today is start by talking about just a brief introduction to myself, and then we'll get into what we'll cover. So once again, my name is Paul Bruce. Right now I'm currently working with the Neotis team as one of their senior performance engineers. You can get at me at Twitter. If you're on Twitter, you can reach me at Paul S. Bruce. And then also you can connect in with me on LinkedIn. I oftentimes will actually work on LinkedIn to have conversations offline with folks, like I'm going to do tomorrow with one of the folks that we went back and forth on an article on. So by all means, feel free to reach out to me, and then anything that maybe isn't covered today, if you'd like a little more information or have a little conversation, more than willing to do that. More than happy to do that. So just a little bit of housekeeping. Like Josiah said, this session is going to be recorded. The discussion is in the chat panel, so please make sure that you also put your questions and answers in that chat panel. We will have some QA at the end of the session, and of course there is going to be a follow-up email to you with links to the presentation, both the resources as well as the video of this. So I just want to quickly understand who is in the virtual room today by asking a question, and we're going to take a poll right now about when do you measure system performance. Now, your systems might be different. It might be a mobile app or a web app, or maybe a backend server, an API, or maybe even just some kind of operations view of things. But in general, when do you measure system performance? Is it just before major releases, just before minor releases? These are multiple choice, so feel free to make sure that if this applies to multiple ones, to multiple answers, we have that as well. So we're starting to see a lot of people answer. This is really great. There's quite a few people who say that this is project-based, as needed. There's also a fair majority, upwards of 21%, say as part of a continuous delivery pipeline. That's really exciting to me because I also actually work in the DevOps space while people are still answering this question. Just a little background on myself. I'm a developer and an avid tester of 15 years. I work with the IEEE. There's a working group on a DevOps standard. I'm also the founder of Grogistics, an independent consulting and research firm. And I oftentimes do a lot of writing and listening. So that's my background, and it's good to get your background and specifically what you do to measure system performance. So let's just take a few more moments to wait for the last responses to come in. Okay, looks like We're starting to see the last few come in. Great. Okay. So what we see is that there's quite a few people who do it just before a major release, of course, and that could also be folks who do it earlier as well. These were not mutually exclusive. So there's also a number of people who do it a few times throughout sprints. That's really good, really important. And then we also see a fair number of people, over 25%, 1 out of every 4 people say they measure system performance as part of a continuous delivery pipeline. That's really exciting. And, it's fair. Sometimes you don't have a schedule for this stuff. A project comes up as needed basis. It just depends. If you're moving hardware around or if you're migrating to the cloud, sometimes you need to do performance. Fair enough. So this is good to know. So what I want to cover today is from an Agile perspective. My background is in Agile and DevOps, and I do some advisement there now outside this day job. So what we'll cover today is a few Agile challenges, and I'd like to really paint a picture how I see what's going on here, and particularly in performance, which also includes anti-patterns. Then we're also going to talk about what the real goal of all this work is, what the real goal of sort of a lot of our Agile theater, or sometimes our Agile processes, and where we're really going as an industry. What's the point? Which is essentially confidently shippable product. And then we'll talk about three keys to efficiency in performance testing, and then we'll do some roundtable. So I just want to start out real quick by a relevant moment in our industry. Right now, we've actually got a bug. I'm sure a lot of you have heard of this, called Spectre, and there's also the other one as well. The reason I bring this up is because what's happening right now is we're realizing that system performance isn't just detrimental to revenue. It's actually imperative to all business models. So every company is a technology company now at this point. So this impacts everyone. But how does it impact everyone? And so there's a few pieces of information. It could impact you up to 14% of your CPU cycles, right? On average, it's about 6. We're currently running these load tests in our own Neotis lab to really estimate the actual damage to typical web workloads and API workloads as part of the Spectre patch. Essentially, this vulnerability came out where there is a patch out, certainly, but the patch reduces performance. And in some cases, we actually see that like big data workloads in AWS, that's the Databricks link. And again, you'll get this whole deck so you can check these links out yourself. This is impacted pretty significantly if you think about the efficiency and the costs to people, right? The thing of it is, though, that there's other research to say that essentially 1 out of every 3 companies or organizations, right, take longer than 30 days to patch and resolve their issues. Now, think about how long that takes. Now, that might be longer than you're used to. It might be faster than you're used to. But think about it. Even if we do patch our systems, now we've got a performance problem. So I don't really know what's better, right? Is it really good news that a lot of these organizations have weeks to months to plan for the impact of applying this patch, right? If we're just solving one problem to find that we've caused another, particularly in revenue, that's a problem. That's a big problem. So I just want to bring this up in terms of every day we deal with performance, whether we like it or not, and whether it's a matter of us actually proactively testing for it or not. And really, when it comes to the point of view, what really matters is customers, right? Their point of view. And what kind of performance do our customers expect? Well, it's more than just a transaction response times from a server, right? It's really the theme of digital and digital transformation now is that there needs to be consistency in terms of brand and, oh, by the way, performance across all digital properties. This includes web, mobile, and API. They want to be able to complete the thing that they're trying to do quickly, right? They want to check out their items. They want to be able to subscribe to that thing or approve that claim very quickly. The other thing is abandonment. We find that page and mobile app uninstalls is a fair thing to measure in terms of what the appetite is for people to hang around when things are performing poorly. And ultimately, we also need to think in terms of what they expect, which is that they're going to be working across multiple connections ubiquitously. So, switching from Wi-Fi to mobile, going over to a broadband connection, their expectation is that your service still works quickly, that your app, that they can do their job quickly. The problem, though, is even though we know performance and system performance is important, we also have the problem of the performance of our organization, right? We've been dealing with this problem as an industry of the businesses wanting to respond to market demand fast, and we, quite frankly, as an IT industry, haven't really been able to always keep up with that demand, right? But we're really trying to improve that situation by things like really adopting the full adoption of Agile over the past 10 or 15 years in organizations, with DevOps coming on, right? The whole point is to reduce that gap and to be able to allow the business to hypothesize more frequently about how to better fit customers. And this is what Agile's supposed to do for us, right? It's supposed to get us in touch more with and become more responsive to our stakeholders. So the good news is that we're actually getting better at going faster. I'm a follower of the State of DevOps report, and from Puppet Labs, and between 2016 and 2017, there was like a 5-time increase in the ship frequency, the delivery frequency, even for low performers, what they consider low performers. So that's a good thing. And it doesn't always mean that infrastructure and configuration as code are patched, right? But what we are starting to see is that this imperative to accelerate is really taking hold for everyone. So yeah, things have changed, right? The industry's going faster. Our monolithic releases are becoming incremental, smaller. We got microservices involved for APIs. We're seeing that cloud migrations are occurring, that there's push button infrastructure, right? Automated pipelines. These are the things that are now modern software. And ultimately, the end user and business expectations on IT are also changing as well. But internally to the team, we're changing the same way. The team dynamics are also changing. We're starting to see smaller batch sizes. We're shifting things left. We're actually shifting things right as well. We're spreading out the feedback that we get and actually applying it in the right places. More frequent testing, more reliable deployment. We're moving into a fully embedded QA and dev and tests in some cases. We're starting to see teams and developers want to take on the responsibility of testing too. And that ultimately moves to feature teams. I've heard recently somebody say that the development teams and the delivery teams are now their own miniature product owners in many cases, because of how quickly changes to features and new features come out. So the dynamics of the team have changed, and ultimately that helps us deliver value to customers. But really, it's the customer centricity of this whole thing that allows the technology and the business to come together and unify over what we're really doing, right? So there are some dynamics that feed in, and that ultimately produces value to customers. But the thing is, I talk with a lot of customers, I talk with a lot of teams, and there are some things that I've heard play out in Agile teams. And there's signals for those who are listening that there's plenty of room for improvement. So for instance, we didn't bother with scalability because they wanted an MVP, a minimum viable product, as soon as possible, right? So we didn't really think about scalability. Unrelated to performance, but I hear it a lot. Well, we'll deliver documentation if there's time at the end of the sprint. Who's heard that? And you know what? Everybody benefits from documentation. So these are those kinds of things that get left to late cycle. Security is also another thing. There's we've been doing stand-ups for weeks and no one mentioned performance criteria. And of course, if that isn't in the definition of done, so the customer shouldn't expect it. Is that fair, or is that putting the horse before the cart? So these are kind of the anti-patterns that sometimes come out when we work in Agile teams and we work in Agile cycles, but we forget that the goal is not faster. the goal is closer and better to the customer expectation. And this is where Agile and DevOps and those movements really come together in their shared and unified voice, right? Faster is sometimes a theater. In reality, we want to get more right about how we deliver. The problem is, and the fact is, that really as humans, we aren't very good at predicting variance in our workload without a lot of practice. Our work is sometimes lumpy, sometimes small and quick to dispense with these work items. Also, sometimes incredibly complex and unanticipatedly so. Right? We can't anticipate how quick they are to deliver. And just because it's hard doesn't mean you can ignore some work. Sometimes you actually do need to make sure that that's done, even though it's a very large and complicated and unexpectedly so thing, particularly in our sphere, performance. Performance can be a tricky, sticky subject. But some issues are still so important that they need and they're necessary to address. So for the rest of today's discussion, I really want to focus on the lumpiness, the three areas, right? Because this is where I really think when it comes to Agile processes, there's a few key things that we can do. Batch size is incredibly important. And there are types of work that work well in automation. Other things don't work well at all in automation. Some things you can lump together and some things you can't. So in this case, finely tuned batch sizes, right? That's a thing that product owners will nerd out about, and really try to figure out how to do this best, and development managers. But really, it's only part of the problem. And so is automation. Automation is very important to going quickly and reliably, but it's only part of the problem. So in terms of types of work, right, we see resource intensive human-only tasks, these things like planning and estimation, prototyping, code reviews. These aren't things you can automate, right? You might be able to get metrics around them, but you can't automate. Additionally, things like resource-intensive automation tasks. Look, regression testing is resource-intensive, whether it's human beings doing it or whether it's lots of computers or mobile devices around the world doing those functional tests. Migrations and upgrades. Oh, man, migrations and upgrades is a monumental amount of work, and a lot of it can be automated and some of it can't. Additionally, performance testing is one of those resource-intensive automation tasks. It still can be automated, but it is resource-intensive when you start to test in the orders of tens of thousands. And then also trend-driven analysis. More importantly, being able to do that feedback loop, that learning loop, right? Automating the build and release metrics is vital now. Also automating the production actuals. Like for instance, what are people actually seeing in AB, in an AB target group about this slight change to a specific page. So in this case, really, regardless of whether you look at it from batch size or workload or estimation, whatever the case is, the fact is right fit is really the biggest challenge. That is just a continuous challenge. And so what I'd really like to do is kind of consider that the context switching and the optimal or disoptimal communication really is some of the things that really help us or inhibit us from achieving our goal. And that right fit, really figuring that out, is very important. So let's talk about the goal for a second. Now that I've painted this picture of, what are some of the challenges and what are some of the problems, what is the goal? Let's go back to the top of the mountain and say, what is it? And from my perspective, it's not potentially shippable product. A lot of Agile people will talk about potentially shippable product. In that, the problem is customers don't want potentially. What they want is real. They really want a product that will work for them, right? It's not about potentially shippable product. It's about confidently shippable product, stuff that it's going to work in production. So you need to be confident, right, that what you ship contains very few issues. And so when we combine some of the things in our industry, like high frequency of delivery, like you got to go faster, and also you got to be more confident as requirements to releasing, it means we need to match our verification and validation strategies, our testing strategies, to the modern reality we have. In other words, our testing needs to be incremental, and it has to handle that lumpiness of work that I talked about a few moments ago. This is where progressive testing comes into play. So let's talk about that for a second. What is progressive testing? Well, let's take a pipeline approach. Let's look at it from an automation perspective for a moment. Like say a feature. Now, I don't mean, some people look at these stages, they think waterfall. In reality, these are dependent events, right? You cannot release something you haven't coded yet, can you? So one follows the other. But what you don't see in the big stage blocks is testing, because testing is everywhere. Testing occurs at every level. And so progressive testing across particularly the framing of a delivery pipeline for, let's say, a feature or even a patch, something as small as a patch, right? There are tactics that you take in order to verify that at every phase, you're meeting the criteria to hand that off to the next phase. Like unit testing, look, if your unit testing are failing, I promise you, it's not going to build. And if it doesn't, or it's not going to deploy properly. And if, for instance, you've got some functional tests, chances are your performance tests are going to inherit the failures that should have been caught by functional tests. So, you can go back over this slide and it would be interesting to have a conversation. It's different for everybody, but ultimately just to paint a picture of the fact that each of these things has goal, right? Each of these things, like unit test, is to verify the implementation, right? To test the implementation. Component and API and functional tests are to verify that we built it right. The validation is to test, did we build the right thing? Is it going to make people happy, right? And then ultimately delivery, there's also things there. Bear with me for a moment. There we go. So from another perspective, if you take a different framing on this, what needs to be performance tested or load tested? Each of the layers in your stack, the APIs, the databases, the third parties, the front-end servers, the infrastructure, the potentially cloud infrastructure or data hosted infrastructure, that all needs to be tested, right? But also the expectations that you have on the system, especially if you have failover or recovery behaviors, right? These things need to be tested. And the question is, from a time budget perspective, if we just go back to the last slide for a second, you notice I put sort of a time budget for testing down the bottom. And in terms of unit tests, they should execute on the order of milliseconds, right, each. And that should be completed very quickly. It should be something that people should be able to do on their own machines, right? You shouldn't have to wait for a build server to run your unit tests for you. Some of the functional tests, on the other hand, might, be slow enough where it's still necessary to do them, but they take a little time. And so you allow the builds to be the trigger for that event. And the time budget's a little easier on that. You might have the order of minutes to execute and complete those things, maybe 15, 20 minutes. I'll show a different framing later that describes this too. When it comes to the number of things that like a regression suite has to do, that might take hours. Honestly, it might take hours to complete the regression test. Same thing with a long-running burn-in performance test or a load test, right? Maybe a manual step that just is an acceptance, a manual acceptance, just to make sure that it's seen by human eyes before it goes out. These have slightly longer time budgets. And so when we think about the different types of tests that elicit different things from different parts of your system, there are some things that can go really quickly. Like, for instance, what fits in a short, fast performance feedback loop are things like database latency testing, things like API performance testing. It's a lot quicker to be able to do a quick spot check on a high volume transaction on the API and just make sure that it's going to be able to handle your larger front end load test that also uses it. And then also some web and mobile API tests. You can actually do some low volume stuff and get some really valuable information out of that. On the order of the longer but still necessary components, there's things like distributed tests that go across multiple network nodes, geographically distributed. You also might need to do spike and things like failover testing. So it takes a little while for the actual test to run your system into a situation where it proves that the mechanisms for failover are working, right? So there are different things that you do, different types of tests that you perform on different elements to elicit problems from different elements of your stack. And so if we think about the different types of tests that you can do, it's a matter of right fitting the type of performance test to both the time budget as well as to the types of issues that are easy and should be captured early. So in terms of some of the early tests, what you're doing is you're looking for the robustness of the code with those quick and easy unit tests, things like basic production activity test. In terms of architectural stability, that takes a little time. Like when you do a soak test, it takes a while. You got to ramp up. You got to sustain that load at a certain volume just to see if the system itself, right, is stable over a period of time. And then ultimately the more you introduce the real world, and I mean by real world, I mean real devices, real browsers, potentially even things like real monitoring systems, APM systems on pre-production hardware or staging systems, the more you introduce that as part of the end-to-end picture, it takes longer. And so we really need to figure out what kind of testing should fit when we're starting to try to do more often earlier. So I have a slide here. I won't talk to it directly, but this is a set of reasons why you might do different types of performance testing. A lot of people have found this really useful. I just threw it in the slide deck to let you know this is here. And if you see that you're doing a different type of test to elicit a different pattern of your system, I would love to hear about that, right? Something that fits in these classic descriptions of what types of tests. So a load test, that tests the development of code and architecture. Obviously, though, a stress test is oftentimes more focused on, sometimes the outcome of that can be capacity planning. So there is a dev and ops perspective on this, but I would love your feedback on this. Ultimately, though, if we look at it from an example, and this is a anecdotal example, it doesn't apply to everybody. It's the concept that matters. That when you think about how you trigger your tests, that becomes very important too. So in terms of, let's just go through this list event-wise. Let's imagine that when you do a code check-in, the maximum time that when your continuous integration system picks up that code and builds it and starts doing the functional test, doing the API tests, and maybe getting to a performance test, that you're on code check-in, you might do a very small test of the database layer, right? Just a pure database load test. You might also do that for your API and for your web and mobile applications. That at the very least, a small test early on at least helps. It's like a little safety net as opposed to a big safety net. At least you're catching the small fish and throwing them back before they become part of the larger load, right, at the end. You really don't want small performance issues to hang up your performance test if you're running it towards the end of a release cycle, something really large. Why have to deal with those small issues at the end? Why sweep those under the rug when you can capture them early and often? And that's the whole point of doing some performance tests when code is checked in. Also, when, if you, depending on your merge strategy, whether it's branching or to trunk or whatever, the fact is when you merge code, right, you might need to run bigger performance tests, but not the massive ones, right? Not the large ones. And I'm using these small, medium, large just anecdotally. Some people have very specific test planning and test scoping criteria. What I mean to say is, small, medium, large, it's kind of like we're talking about performance test coverage over the volume that you test at, the number of workflows, right? The scope. Is it 10 or 20 of your workflows that you're using as tests? Or is it really only like a few narrow critical workflows in your business model, right? So the number of scripts or number of flows different from the volume of testing. And then also that last part from the previous slide where we were kind of talking about the end user experience, some of these conditions like to bring in the concept of getting real mobile devices to sample what it's like on a 3G network when your system is being tested under large, tens of thousands of user load, that the realism or conditions, geographic distribution or networks, all that stuff really changes the total sort of t-shirt size for your tests. And so that's why I have this general grid that basically says, look, overnight, you might run some medium or even a few large tests on each of these components. But, this is the type of thing that especially people who are primarily performance engineers and QA teams should be kind of working this out for themselves, working this out with the dev teams. You might have a different version of this for different components that you're asked to be part of testing with. But the whole point is to visualize what's going on and then have a shared agreement about how does this really work in particularly a pipeline and an automated pipeline that allows us to fit to Agile flows. So here we come to sort of the three things that I'd really like to bring to the table. I've offered a lot of context and suggestions, but really at this point, what I'd like to turn over to you and say, here are some things that I know from experience help you efficiently performance test. And efficiency is key to Agile cycles. Anything inefficient is going to take too much time. And then we're not going to either be able to find time for it in the cycle, or we're going to have to get backlogged on something else. So the more efficiency we have in our processes and in our testing, the better it is. So the first thing is to, it's all about priorities. It's all about prioritization, folks, right? You can do a million things and burn yourself out, or you can prioritize and do the right things, a few of the right things. And so the first thing I want to say is what we need to do is integrate performance all the way into our planning phases. So that first suggestion, I actually have data for. I ran a study last year, where one of the things that I wasn't even intending to come out with, but it was a happy accident, was that we found that when we asked people how many of their user stories, just give a percentage of their user stories that contained performance criteria, when we also asked them the question of how frequently do they deliver production code and have that out in production, what we found was that the people who are releasing literally every other day, right, very quickly or even earlier than that, faster than that, they have double the number of user stories that include performance criteria. Essentially, when you plan for the work, you have no excuse not to do the work. When you plan to say, this performance criteria, we're going to put that in the user story as part of the larger acceptance criteria, and then we're going to meet it. It requires you to figure out how you're going to meet it. And so the question is, well, how do we do that? And here's a few ideas, just a few ideas. And many of them are not mine. I'm just learning, I'm a learning person as well. So the first one is, if we want to know how we bake performance in directly to user stories and thereby Agile cycles, we need to think about what it means to the definition of done. Whether you have that or not, there's this idea that done is done in some way, shape, or form. So sometimes that means back of the card, right? Think about the user story as a card, and on the front of the card, there's the, as a somebody, I want this thing because of this reason sort of model. Well, on the back of the card, that's where your acceptance and performance criteria goes, right? Maybe your entry and exit criteria for those things. So that's one thing. The other thing is a quote from Back to the Future, Doc Brown, you got to think fourth dimensionally, Marty. You got to think about the concept of time, right? When are we going to do this, for one thing, from a scheduling perspective? Also, over a period of time is a good question to ask when somebody says, well, I want the system to handle 1,000 users. Really? Over what period of time? A minute? A week? that changes the parallelism. It changes the total concurrent number of users and thereby transactions or requests per second that you have to hit as an SLA. So you always got to push back on people when they say, I want it to do this much. Well, this much over what period of time? Just ask that question. The other thing is any kind of concerns and any guidelines, right? It matters when you capture this stuff, right? Any kind of concerns that people have over what they know about a system should be captured as part of that user story, in the sense that that might be a consideration that they want to take. And then also guidelines. If there are organizational guidelines over what performance should be, you definitely need to bake that into your user stories if you're going to think about performance as part of them. And then the last thing is, from a concurrency perspective is one way. Also from the conditions, right? You might want to think about, well, where does this come from? And I've got a really great example of these things right here. So this is an example, comes from an article on Tech Beacon from Todd DeCapua. And he has this example. There's a couple of different examples like this, but it's one thing to say, to write the front of your user story card as an automotive driver, I want to be able to remotely start my car so that it will be warmed up. But the important part is by the time I get to it, because if it's warmed up 30 minutes in and you've had to sit in a cold car, it's not satisfying the person's intent. So to capture the time component of a user's intent as part of a user story is critical, because then you can flip the card over, so to speak, and start focusing on specifics about what it would take to actually accomplish that, or what is expected as an outcome from that, right? The app launch time, things like it must handle X number of requests. This is where you start to solicit and elicit from the dev teams, from product managers and product owners, the fact that they can't ignore the importance of performance early on. And the way that we get that on the table is to talk about it early in planning. The second thing is to be able to, the second key to efficient testing is to establish right size feedback loops. We talked about this earlier, right? Sometimes small load tests, but small load tests on what? Well, entirely new, undiscovered territory, things like new features. Small load tests required on new features aren't a bad thing, right? What they allow you to do is to be able to get to the point where you're actually providing value back to the organization. An example of this, the next thing we want are things like, well, let's figure out what those critical paths are in our business that then we need to make sure is part of performance regression, right? And internally, one of the things we do is we make sure that we've got a new SaaS product. So that's a web-based view you'll see in a moment. But, one of the things we're doing is making sure that we're, eating our own dog food. We use our own product on our own stuff. We make sure that those performance tests are regression tested, are part of our regression strategy, so that we know if something we did in an upcoming release degrades both the performance, not just the functionality. Here at Neoload. The other thing is, sometimes with right-size feedback loops, you want to be able to deliver that information to the right people. And sometimes you don't always know who those right people are. You might be in a team that doesn't have line of sight to the other team. So in terms of turning the feedback around, you want baselines and comparisons that everyone can access. And then ultimately, what we really also need to make sure of is that we have metrics that tell a complete story. It's not just about how much load the thing can handle. It's what happened during that load on the server side. Also from a customer's perspective, how slow did the browser go, right? So the efficacy of the test is about load and bias of the load test itself. The impact side of the story is what impact did it have on the server? And then when it comes to the end user experience, right? How long did it take to load that document or make that AJAX call? So actually, I want to switch over real quick and kind of show you what that looks like from a real-time perspective. And I have the opportunity to work with the Neotis team and to kind of do presentations and work with customers on that. One of the key things we did last year is release a web-based dashboard system that allows us to start to really build a platform for performance that extends beyond a single person or single team. So what you're seeing here is, we'll switch over to the test results. I just ran a test earlier today. You can see that we get these performance test results of a test that ramped up and held the load for about a half an hour. And then you get kind of the high level overview, right? This is just an easy way to just go, oh my goodness, this is something that we can share with the rest of the team. And by the way, when we run a load test on this platform, the data is real time. So when we run this, people can see what's going on. They can go investigate as the test is occurring and potentially make configuration changes on the back end to help resolve, to try to triage and fix what's going on. But in this case, we've got the results of a test. We can even move them over to a dashboard and start dashboarding some of this stuff out, really starting to tease apart the components that I just mentioned. You know, the load test itself, this is just a simple graph saying how much load, how many virtual users were used. I've also got some metrics on the results time, on a specific transaction that was occurring, a specific point in the workflow. I can pull that information in. I can get average duration, all sorts of stuff. We can get throughput and time to first byte, all these raw metrics. But the more important thing is to take these metrics together in a shared view, and not just a shared view so your brain can look at it, so that you can look at it and go, I think this might make sense to me, but to actually incorporate others into that conversation, be able to look as let's say a quality engineer or test engineer, is to sit with a developer or remote screen share over to a developer on the team and say, hey, let's look at this together. Maybe share that link to them, and then they can look at it. And that's why we've built NeoLoad Web to be able to do these kind of things. These dashboards are entirely customizable. If I want to pick a particular part of a workflow and I want to go down into the specific details of, maybe the load of the home page, if I want to go and pick a specific request out of this and grab the throughput of that request, I can do that simply by dragging and dropping onto the surface. So I could just go ahead and in real time actually get that information. And so can your friends. So can the people that you share this dashboard with. They can tease apart the data from their perspective. And from their perspective might also mean on the operations side or on the infrastructure side, the monitors that were involved in that test, monitoring the systems involved. So one of the great things about our platform is not only do we provide you an ability to easily spin up load tests, but we can help you monitor the server health metrics as you go along as well. We can also integrate with APM tools. So you can start to see that there's a lot of information that we have to deal with in aggregate. And we can pull things like, a specific transaction in our workflow. We can also pull things from like the database side. We support all the major database platforms, the application service level, the web server level, and the operating system level on most of the major platforms there. So Linux, Windows, Mac, Internet Information Services, Apache, IBM WebSphere, all sorts of stuff. Once you're ready, you can share this out. You can click the share button, and that shows up for other folks on the team, on your team in this dashboard. Now, this product started out as a SaaS product, and that's what you're seeing now. But the exact same product can be hosted on-premise. So for folks who are, have regulatory compliance or specific security concerns, this just happens to be today the SaaS platform. But you can actually take this. We provide Docker containers and installation path for an on-premise, all on-premise version of this. The other thing is that when we get to dashboards, one thing we want to do, particularly in continuous integration cycles, is to be able to have the CI system kick this stuff off. And so when it kicks it off and it comes back, the results might be visible in Jenkins. We might get a notification in our chat ops, but we need to have a shared way to see build over build or test over test trends. And that's what you can do with Neoload Web as well. So in this case, I've got this this test that I ran earlier. Now I only ran 2 or 3 tests. So, today's build trend went down, went back up again. But if I look at something else here, something that we are regularly building this code base, you can see that the trend, particularly in terms of transactions, is along the same line. So transactions per second isn't changing, but the time cost of those transactions it's being reduced this build. So you can use this in your stand-ups to kind of say, are we better today? Are we worse today? And that becomes really beneficial as a feedback loop. So I'll switch over real quick and go back to the next part, which is the third and final key. Right? It's one thing to be able to turn around these pieces of information to the team quickly, right? But the other thing is, how can you do that unless you have a way to be able to script very quickly, right? If you've got new features flying at your face and you need to build the load test out, you need to start with what's the script. And so some of the things that you need in order to accomplish that, particularly in fast agile cycles, is that, you need to be able to record through the browser or the phone, and so there are load code approaches like Neoload, which we've been doing. Then there's also the ability to carry customizations, like when you change a script, you want that to change with you during rescripting and recording, and we can support that as well. This is something Neoload does really well. Also building a library of reusable test assets. So, all the functional testers in the room probably know what I'm talking about, but sometimes performance testing has become, traditionally, it's been hard to reuse certain assets. Well, we've been working hard to help Agile teams do that in Neoload. We also want to reuse functional test assets if we can. If we're already scripting something, why not turn around and use that for a load test? And in that case, one of the things that we do here is we try to provide what some of our customers have called self-healing load scripts. So the ultimate goal, though, is that once we do this, we're efficient, and then we can also share these test assets across teams and engineers. And in terms of Neoload, we support that by doing a real-time recording. We help you reduce waste in scripting time by recording live. And I want to actually kind of share one more time the screen, kind of show you what that looks like in Neoload. So we went from a web dashboard down to the designer and controller software that you would have on your desktop here. You can get the same graphs. In fact, you can get some additional information if you were to, let's say, run a Selenium sample, right? You can get that over here, the DOM load time, because you're running a subsample of real browsers. You can do this kind of stuff very quickly and easily, like I did a half an hour before this presentation, right? With a little bit of knowledge and a little bit of knowledge about the tools and about the systems. In terms of design, though, we've got a couple of examples here, and typically what we do is we have a lot of people, they like to use a browser, so they would just click the recording button and start the recording. But we would walk through the browser, right, to get a recording of traffic. And what we are doing is recording real requests and responses. We're not clicking buttons once we run that load test script. We're actually throwing requests and responses at the server because that's highly scalable. But what happens if I want to re-record something, right? What happens if I originally recorded something, but I changed that test a lot? I added some customizations around how to handle the test environment, like updating some kind of session token early, or let's say I have a shared component in there. What about if I wanted to start injecting data into my tests and use variables and start to customize my scripts? What happens if they ship me a new version of that test that changes things around? Well, this is one of the things that we provide is support to help Selenium, people who are using Selenium, be able to reuse their Selenium assets. And in this case, I just happen to have IntelliJ, but Maven works as well. This is some code, some sample code from a Selenium script that one of our customers I took it and adapted it to our system, but this was the type of coding that they were doing. And when we actually run this in design mode, it might incorporate new functionality. So I actually want to do that right now. I'll press the play button here. Sometimes you get handed a jar file. Sometimes it's a DLL if you're running, let's say Selenium, you're writing Selenium for .NET. So in this case, I'm actually just going to play this out. And one of the things you're going to see when we hop back to Neoload is that as it's actually playing that, that Selenium test, we'll see two things. We'll see that it's running Selenium, right? So if my computer will allow it to. Okay, great. It's running Selenium. It kicks up an automated browser. So this is a real browser that's running this Selenium script. And in the background, you notice this new recording here. And you notice that Neoload has switched to recording mode automatically because we've allowed you to basically wrap your Selenium driver in our driver to capture this traffic as your Selenium script is running. So without necessarily even having to manually go through the same workflow, you can just reuse your Selenium assets. And we have a few other situations where functional comes into play. But we found that teams are really starting to use Selenium as their default motion. So what you're seeing is the browser being automatically run by our Selenium script in the background. When that's done, the test will pass. So imagine if you were executing these things in a CI cycle, right? How do you refactor that old test? And so one of the things after it's done is it's going to take Neoload, and Neoload is going to apply its smart engine in the post-recording process to pick up on any customizations from the previous script. And so what it'll do is it'll actually create a new script that, just like the old script had some customizations, had some variables. Well, now when we look at that new version of the script, it's got those customizations in it. It's also got, by the way, new functionality that wasn't in the previous test. The situation was maybe we had to upload a photo this time, and that changed the traffic pattern that we captured. It has included that automatically. Instead of creating a blank new recording for you, it retains the customizations from the previous script. So as you can see, there's still variables in here. There's still my customizations from last time around, but because I was given a new Selenium script, it includes new traffic patterns, and it recaptures what I did before into my new script. So in a matter of literally like 5 or 10 minutes, I can turn that around. That also works from a continuous integration process in terms of the pipeline. So we talked about integrating this into your pipeline. Well, with Neoload, one of the things that we do is we run Neoload in what's called a headless mode, or in a command line driven mode, and so that allows us to integrate quite directly with things like Jenkins, Bamboo, and TeamCity, and we can integrate some of the basic customizable dashboard elements into the Jenkins project dashboard, but we can also benefit from those back in Neoload Web. So if you're running Neoload Web and Jenkins running Neoload, that information will show up in your Neoload Web dashboard too. So in this case, I just had a quick example just to show you that this indeed does fit into a CI pipeline. And so all the stuff that I said earlier about, time budgets and what it took to accomplish this, you can also inject the right size performance tests into something like Jenkins pipeline or some other automated deployment or CI system. So now that we've kind of taken a look at some of the specifics about how you might do that with a platform, I just want to circle back on this last part and open it up for questions for the last 5 minutes. Think about it. The 3 keys to efficient performance testing. Start the performance planning cycle early. That's not always easy if you're outside the planning team. So get inside the planning team, right? Start to ask the questions in order for you to accomplish your job. Make sure that people understand how to do that. That second thing, establish right-sized feedback loops. There's a number of slides in this deck, and I would love to go back and forth with you if you have any specific questions on how to do that to you. But it is different, and it takes engagement to find the right-sized feedback loops. And then the last thing was reducing waste time in scripting and analysis, right? Particularly in terms of those graphs that you saw, it was very quick and easy for me to navigate right to the problem that occurred on my server, to be able to visualize these different metrics together so that we can isolate out, is it the network, or is it a server, or is it just the APIs? That's very important, as well as the scripting time. So I just want to finalize by saying what we covered was obviously the challenges in Agile, the big challenge now, some anti-patterns. We level set it on a goal of being able to confidently ship product that you know in advance what your risk is in terms of performance. And then we talked about specifically how you might do that, not just with tools, but also with people and process in the mix. So I'd like to turn it back over to Josiah. Thank you, Josiah. And we can go through some questions at this point.
All right, perfect. Thanks so much, Paul. Just a reminder before we start Q&A, you can ask Paul questions by typing them in the field beneath the panels, then by clicking the submit button. We have a few minutes to answer some live, and then everything else we don't answer live, we'll be able to answer offline. Wanted to start right here, Paul. This person wants to know who in the company should do or create or maintain the performance testing. He mentions that we have many feature teams and they have dev and QA engineers.
That really depends on the appetite at the organization. I know of many customers who have great dev teams, but what they've done is they've divvied up the responsibility of writing tests. They've got really great criteria. They can very clearly articulate their goals and their specific points in their story. And so, they might have an outside QA group. They might have an inside QA group, right? It really depends on how the organization best finds the right fit in terms of time. But I would suggest that you look at it in terms of time. One of the key indicators of why people come to us, come to Neoload and Neotis over a monolithic dinosaur of a load testing tool is because of the time it takes to turn these things around. So I would highly suggest you frame this in terms of how long, pardon me just for 1 second.
Talking for an hour can be difficult, don't worry about it at all.
Okay, so the other question here I see pop up is, does this tool handle more than 10,000 concurrent users at once? Yeah, yes, we do. Load testing gets split across various load generators around the world. We can host those for you. You can spin those up on your own infrastructure, whether that's on-premise in a data center, in various satellite locations around the world, or in the cloud, in your own private cloud. So it really just depends on where you want to put those load generators. But yeah, absolutely. We have people who run hundreds of thousands of virtual users at a time through our tool.
Okay, perfect. I saw a couple people asking about being able to download the slide deck. If you look at the bottom of your screen, there should be a handouts widget. You'll be able to download some different PDFs and white papers from Neotis, as well as the slide deck itself. If you're okay with it, Paul, let's do one more. We can close out. This person just want to know, does Neoload work with other CI systems?
Oh yeah, I mentioned Bamboo and Teen City. Absolutely. There are other questions about like who manages the CI system down in the chat. Really, it takes all kinds, and it really takes involvement. So what we see in DevOps organizations is that they've got high degrees of involvement across, regardless of who writes the tests. There are test engineers, there are performance experts, there are site reliability engineers, there's operations and dev in the room together planning this out.
All right, perfect. And that gets us to right about to an hour on the dot. Again, we'll be able to answer those we didn't answer live offline. That ends our event for today. I'd like to thank our speaker, Paul, for his time. I'd like to thank Neotis for sponsoring this event. Also, a special thank you goes out to you, the audience, for spending the last hour with us. Have a great day. We hope to see you at a future event.